Hello, I'm Robert with AWS. Welcome to Continuous Everything, moving to DevOps on AWS. If you give me your attention for the next 30 minutes, here's what you're going to learn. You'll hear about the origin of DevOps, where it comes from, and why it's important for your business. You'll hear about how AWS thinks about DevOps, and as a result, what kinds of tools and services we've built on AWS to support DevOps workflows. And finally, we'll end with opinionated solutions for achieving the capabilities and benefits of DevOps on AWS. Where did DevOps come from? It's really important that we have some notion of a shared definition of DevOps, because this word, while it is the amalgamation of development and operations, this word means a lot of different things to a lot of different people, companies, teams, and organizations. And I think the best way of trying to get around this definition problem is to study the origins of this set of practices. Now, I want to take you on a quick tangent. Because we're about to tell the story of DevOps, we need to tell a good story. And a couple years ago, I took a storytelling class from a couple folks who used to work at Pixar. And they told me, Pixar stories are great. And there's a reason why they're great, because they always start with one very, very simple concept. And that concept goes like this. Once upon a time, blank, until one day, blank. I was surprised to learn how simply all Pixar stories started, and I want to apply that to DevOps. So here we go. Once upon a time, we used to buy packaged software that sat on store shelves. Once you bought that software and installed it, it never changed. Until one day, we saw the advent of broadband internet, and that access proliferated across the world. Now, when broadband became generally accessible, software companies had to understand how to operate in this new model. But what kind of model were they operating in before? Well, when software companies initially realized that they could make money off of software, they borrowed concepts from other manufacturing industries. And the processes that other manufacturing industries looked roughly like this. They would go start with a research phase to understand what customers wanted and what the product should do. They would then design the product, develop the product, as in build it out. They would test it for quality, and then release it, and then maintain it over time. When this model was brought into the software industry, we began to refer to it as waterfall, or the software development life cycle, SDLC. And this model is still very, very common. In fact, if you look around at the titles of the people at your software company, you might notice this. Titles in software companies tend to align with these different roles. For example, a software engineer is typically associated with the development phase of the SDLC. A software architect might be associated with the design phase. QA analyst, that's testing. Site reliability engineer, that's maintenance. And researcher, I think that one's obvious. But again, as applications started to evolve in this world of high-speed internet access, we started to see more and more connected software that received regular updates after initial purchase and installation. And we started to see the rise of App Store models that relied entirely on digital distribution. The combination of broadband internet access and this kind of infrastructure enabled companies to achieve shorter and shorter times between when they updated their software and when customers got to use these new features. In fact, this culminates in Windows as an example, Microsoft Windows. The entire notion of holding back improvements to your software for a major release now seems quaint. After all, if you have new features that will improve the quality of your product today, why not release it as soon as possible? Microsoft used to release a new version of Windows every few years. But now, it seems that Windows 10 might be the last version of a Windows client. That's not to say that Windows 10 will never change or never improve. Quite the contrary, you've probably seen Windows updates on a regular basis. Windows 10 is going to receive continuous improvements. But Microsoft doesn't see a need to release a Windows 11 or a Windows 12, and so on. Which brings us back to the conversation of what happened with the SDLC or the waterfall model. Well, it turns out that when companies try and release rapidly, frequently, even continuously, they encounter some bottlenecks with this process. Let's take a look at some of these bottlenecks. Under the waterfall model, many software companies built organizations specifically to handle release engineering. And now this phase would generally happen after most development and testing had concluded. And you see this pattern happen when the software is turned into what's called a release candidate. The release candidate would be thoroughly tested, and during that testing, you might have a code freeze so that all the testing is valid with respect to the code base. And this kind of model typically results in these strange interactions where you say, okay, well, the release engineering team is testing the release candidate. There's a quality issue there. That's not my problem. It also leads to much longer lead times, because if you have to go through this enormous process over and over again, it's much harder to integrate feedback. Let's say you discover an issue during release candidate testing. It's very hard to get that feature checked in if you're in the middle of a code freeze. Now, again, I mentioned that this model is still alive and well. In fact, the best example of this is in the games industry, where a lot of games still sit on store shelves, and so they go through this release candidate testing process. But for a lot of other applications, various companies have independently discovered that a continuous model can get past a lot of these bottlenecks. What are the benefits of this continuous release model? Well, first, teams that use a continuous release model achieve a higher velocity. What I mean is they can implement more features in the same amount of time. And velocity is extremely important, not just because of the release cadence, but because of the opportunities that it provides for the team to gain valuable experience. You've often heard of velocity and quality being couched as trade-offs, as in the faster we build the software, the lower quality it will be, or the higher quality you want, the slower we have to go. But I disagree. I've observed that velocity and quality are positively correlated, because higher velocity leads to more practice leads to more experience, and more experienced teams build better quality software. Of course, that takes us to the next benefit, quality. Now, if the team notices a bug, they can fix it as quickly as the release model allows. There are benefits to the scalability of the application. The team, by constantly releasing new updates, has a deeper understanding of how the system operates and scales, which enables the team to tackle the inevitable challenges that come upon the service as the system grows. And best of all, this means that there's as little waste as possible when the team adds scalability changes to the system. Finally, there are significant benefits to the culture of the team that uses a continuous model. Continuous releases means that the team is closer to the customer. And this not only improves the ability for the team to build what customers want, it also energizes the team. At Amazon, we call this phenomenon single-threaded ownership, and it's extremely important and powerful. Now, these are all very tantalizing benefits, but in order to keep this flywheel turning, you need a set of practices and tools that we have collectively come to refer to as DevOps. At AWS, we think about DevOps transformation as a set of layered capabilities. At the bottom, the foundation of the pyramid, we have culture. If your company has not established a DevOps culture, you will need executive support and a willing staff. Culture cannot be automated. Case in point, a lot of companies jumped on the microservice bandwagon to solve what were actually cultural or organizational issues. And it's not surprising that these companies walked away disappointed and disenfranchised. After we have a foundation of a strong culture in place, next up we have observability, CI/CD, and infrastructure as code as what we call foundational capabilities for DevOps. Observability refers to the ability to know what's going on in your application. And this may span logging, analytics, crash reports, distributed tracing, monitoring, etc. CI/CD refers to, respectively, continuous integration and continuous delivery. Continuous integration is the practice of merging code changes and running automated tests on a regular basis. And continuous delivery is the ability to ship changes to customers safely, quickly, and sustainably. Infrastructure as code is exactly as the name implies. Just as we have source control for source code, we also need to be able to track and understand changes for underlying infrastructure. And this is critical to security. Imagine that you've just started your new job as the CISO for a software company. And your head of IT comes over and says, hey, we've got an AWS account. There's a bunch of stuff in it. Tell me if it's secure. That job is much easier if you have infrastructure as code. Now, finally, at the top of the pyramid, we have the fruits of a mature DevOps operation, which is continuous compliance, continuous auditing, and even the ability to predict and alleviate features before they become difficult to deal with. Now that we understand the set of capabilities, let's turn over to look at the tools and services we've built to enable those capabilities. For observability, we have Amazon CloudWatch. CloudWatch collects data and provides actionable insights across your entire application stack. It natively integrates with a whole host of AWS services. You can use CloudWatch to monitor individual metrics. You can generate dashboards from CloudWatch. You can even use it to optimize resource utilization. In summary, you can use CloudWatch to get a unified view of the operational health of your entire application. Next, we have AWS X-Ray. If you have a service-oriented architecture or a microservice architecture, you know that application logging within one compartment of the call stack is not sufficient to tell you what's going on. You need to have some notion of what's called distributed tracing. That is, what happened to the request as it hopped from service to service, from front end to back end, and all the way back. That's exactly what AWS X-Ray does. It provides an end-to-end view of requests as they travel through your application, and it shows you a map of where you are seeing higher latency, seeing error rates. And then we have the recently released Amazon TimeStream database. Amazon TimeStream is a fast, scalable, and serverless time series database for IoT and operational applications. You can store trillions of events every day in TimeStream. And you can use TimeStream to build custom solutions for all sorts of different observability needs. For CI/CD, we have AWS CodeCommit. CodeCommit is a fully managed serverless source control service for Git repositories. We have AWS CodeBuild. CodeBuild is a fully managed continuous integration service that compiles source code, runs tests, and produces software packages that are ready for release. We have CodePipeline, which automates the different phases of your release process so that every time there's a code change, you can start to run that pipeline, and this enables you to rapidly deliver features and updates to your users. And the great thing about CodePipeline is that, like all these other services, it supports granular IAM permissions, identity and access permissions, which means that you can have declarative, fine-grained access control over which employees can see which parts of the code pipeline. Finally, we have AWS Code Deploy. Code Deploy is a fully managed deployment service that automates software deployment to a variety of compute services, such as EC2, Fargate, Lambda, and even your on-premise servers. Code Deploy is very interesting. The way this works is that for instances like EC2, you have what's called the Code Deploy agent running on that EC2 instance. And the Code Deploy agent works with the Code Deploy service to perform things like rolling updates to your application when you have a fleet of EC2 instances. We'll see an example of this shortly. Finally, we have infrastructure as code. Under infrastructure as code, we have AWS CloudFormation. CloudFormation gives you an easy way to model all of your related resources, whether that be within AWS or third-party resources, and you can provision them quickly and consistently using a declarative YAML document. And this makes it really easy to manage this lifecycle, the lifecycle of your entire application stack, because it allows you to treat that whole stack of infrastructure as code. We have the AWS CDK, which stands for Cloud Development Kit. This is an alternative way of defining infrastructure as code. Whereas CloudFormation lets you define infrastructure as code declaratively in a YAML document, the CDK lets you author that code in programming languages such as JavaScript and Java. And this allows you to programmatically and imperatively define your infrastructure as code and then check it into source control. Under the hood, of course, CDK uses CloudFormation. And then, of course, we have AWS IAM, Identity and Access Management. This is our meta service that provides declarative, granular access to all your AWS services and resources. It does this by building what are called IAM policies. Policies are documents that contain all the rules about what actions are allowed by which principles. Moving to the very top of the pyramid. These are again, the advanced capabilities of continuous compliance, auditing, and prediction. We have a service called AWS Config. AWS Config is a service that enables you to assess, audit, and evaluate the configuration of your AWS resources. It continuously monitors and records the service configuration and evaluates that against your desired configuration. We have CloudTrail. Now, CloudTrail can log and monitor any sort of account activity across your entire infrastructure footprint, whether that activity be from somebody clicking around in the console to running CLI commands to running SDKs, or whether those changes come from other AWS services. We mentioned CloudWatch earlier, but there's an advanced feature in CloudWatch called anomaly detection. For example, let's say that you've configured CloudWatch to watch aggregate CPU usage across your EC2 fleet. You can use anomaly detection to detect spikes in CPU usage or gradual increases in CPU usage that a human being might not be able to notice. And then you can configure that to set an alarm. And finally, we have DevOps Guru. And even though this service is just in preview right now, I still think it's very worth mentioning because it contains a host of very interesting capabilities. DevOps Guru applies machine learning models to detect anomalous application behavior. It tries to gather all the contextual data to diagnose a root cause, and whenever possible, it even provides a recommended remediation for that issue. Now, I know I just went over a lot of different services and features. I don't expect you to remember them all, but I hope that they will become a little bit more clear when we talk about how they fit together in terms of solutions. I want to go over two opinionated solutions that combine some of the tools and services that we just discussed. The first is an opinionated CI/CD pipeline using AWS Code Pipeline. Now imagine that you have an application and you have two AWS accounts. You have a production account with a fleet of EC2 instances running the binaries for your application. And then you have a development account, and then you have a dev environment corresponding to the development account. You also have a repository somewhere. In this case, it's AWS code commit, but this can be a Git repo, this can be on GitHub, this can be on GitLab, whatever your favorite source control service is. And that's where your developers check their code in. Now the question is, what lines and boxes and components can we fill this out with to understand how to automate as much as possible to get that code reliably, safely, and securely from that repository over into the dev environment and the prod environment? Well, first, we're going to set up AWS Code Pipeline. And what Code Pipeline allows us to do is to respond to commit actions against our source control repo. And in response to the action, typically what we want to do is to build and test. Anytime we detect a change in the release branch of our repo, we're going to build and test. And AWS Code Pipeline does this by calling out to AWS Code Build. It's going to try and build a deployment artifact containing all of our application with its latest state, and it's going to try to put that into an S3 bucket. And if that build is successful, we can then run a series of automated tests. If those tests pass, then we can move on to the next stage in the pipeline. And here, we're going to deploy to the dev environment. Again, Code Pipeline will call out to Code Build, and it'll say, hey, Code Build, let's go and update the dev EC2 instances. And the way this happens is because the dev EC2 instances are running the code deploy agent. And the code deploy agent will reach out to the S3 bucket, pull down the latest binaries, and work with the code deploy service to execute whatever sort of deployment strategy seems best fit for the dev environment. I'll talk about the deployment strategies in a little bit. Once the dev fleet has been updated to the latest version, we can run yet another set of automated tests. For example, tests here might involve integration tests as opposed to just unit tests. And if those tests all pass, then we can trigger the final stage in the code deploy, the code pipeline, which is to deploy this service to prod. And it'll do this again by calling AWS Code Build, which, because this calls in from the dev account to the prod account, it's going to need to assume a cross-account role in prod using IAM. And then once it gets into that account, it will then trigger code deploy, which will work with the code deploy agent on the EC2 instances to again pull from the S3 bucket and then update the application. And it can update the application using a variety of different strategies. Out of the box, code deploy has 3 strategies, one at a time, half at a time, and all at once. One at a time is, as its name implies, it's going to take a look at the EC2 fleet and say, hey, let's try and update one instance at a time. And after every time it updates the instance, it'll check for the instance health. And if the instance is not healthy, it will abort the update, and then you can perform a rollback. Half at a time is just splitting the entire fleet in half and updating one half at a time. Both of these strategies allow the application to continue to serve traffic as the update occurs across the fleet. All at once is the most aggressive strategy. It tries to update the entire application at once. And so this is the one where you should only run this strategy when you're very confident in the quality of the update. So there you have it. This is how Code Pipeline, Code Commit, Code Build, and Code Deploy all fit together to build an opinionated CI/CD pipeline for your workflow. Now, one thing I want to emphasize here is while this example contains 3 phases for Code Pipeline, these phases are entirely configurable. For example, if you have a dev environment, you have a QA environment, you have a pre-prod environment, you can define phases and deployment and customize Code Pipeline to fit your exact workflow. Let's move on to the second solution. Now let's say that your application has followed a lot of the best practices that we've talked about so far, particularly with observability. You have instrumented your application to write logs variously to CloudWatch. CloudTrail is tracking all of the account changes. You have configuration changes being tracked in AWS config. And your microservices are observable by way of using AWS X-Ray for distributed tracing. That's great. But imagine if there's an issue where one of your developers goes in and changes a configuration setting. Let's just say they change the number of concurrent instances for your Lambda function. Okay, well, that change might show up in CloudTrail. And then let's say that that caused an increase in error rates or an increase in latency, which shows up in CloudWatch. If that data is all there, it'll take a human being to go through and act as the detective to try and understand what caused what. And this can be time consuming. It can generate fatigue for your operations team. What if we could automate this? That was the genesis of Amazon DevOps Guru. When you start with DevOps Guru, you configure it to ingest data from a variety of different sources, such as CloudWatch, CloudTrail, X-Ray, etc. DevOps Guru then applies machine learning models to try and gather the context, like, hey, somebody made a change, and we have that record in CloudTrail, and then we saw elevated response times, increased error rates in CloudWatch. We detect this configuration drift. What's the relationship between all this? Or is it just noise? Right? So DevOps Guru can take all this information and digest it for you and act as that automated detective. And then whenever possible, it can even provide a resolution. It can say, hey, I think the issue here is that you don't have enough provision concurrency for your Lambda functions after the last change, or after a new function version was deployed that has higher latency, you need to increase the provision concurrency. It can try and assess all of that for you. And it does so automatically. So as you make changes to your infrastructure, as you make updates to your application, all this stuff is running continuously. But of course, how does it tell you that something is wrong? And here it will integrate with popular services like SNS and Systems Manager, and even third-party services like PagerDuty. So DevOps Guru is really a great example of how you integrate all of these advanced capabilities on top of the foundational components that we covered. And this is going to allow you to generate a whole set of insights into your application. It gives you predictive power. It gives you very, very quick first-level diagnosis of the relationships between the recent changes and some of the issues I might be seeing. And it gives you the best possible chance of getting ahead of issues before they turn into serious problems. So there you have it. Those are the two solutions that I wanted to share with you during this talk. Quick reminder of everything that we covered today. We talked about the origin of DevOps. We talked about why it's critical for your business. And we talked about how AWS thinks about DevOps. As a result, what tools and services we built. And we ended with two opinionated solutions for how to achieve some of these DevOps benefits on AWS. Thank you very much for your time. Thank you for listening. I hope this was valuable to you. My name is Robert Zhu, and I would like to request that you take just a few moments to fill out the session exit survey. As a company, AWS thrives on feedback, and this really helps us make this content more valuable for you in the future. Thank you, and have a great day.